Okay. So here's what we have. Secant of x times cosine of x. You are going to be utilizing that very front page of your notes a lot today. You're either going to be using those reciprocal identities, the quotient identities, or the Pythagorean identities. So if we have secant of x times cosine of x, I'm trying to see if I can change one of these functions to something else, but it means the same thing, and then see what can cancel out. So secant of x, in your notes, secant of x is equal to 1 over cosine of x. Yes?
Yeah.
So I'm going to change secant of x to 1 over cosine of x times cosine of x. So secant of x, I changed to this. I kept cosine of x, cosine of x. You see what I did? Now we want to see, can we cancel and simplify? Yes. 1 over cosine of x times cosine of x over 1. Notice these will cross cancel, leaving you with 1. That's your final answer. 1. Okay. I'm going to give you a little trick. Usually, if it says cotangent or tangent, you almost always want to use the quotient properties, the quotient identities. Because if you'll notice, cotangent and tangent, they can be written like this, or they can be written like that. Most of the time, if you use the quotient identities, you're going to be closer to getting to the answer. So cotangent of x is the same thing as cosine over sine. See that? So that's what I'm going to do. I want to change cotangent of x to cosine of x over sine of x times, and then bring down sine of x. Kind of like the very similar, or the problem that we had earlier. We have some cross canceling that goes on with the sine of x's, leaving us with simply cosine of x. We now have one trig function. That's what we're trying to do. We're trying to figure out how can we change these up to get to one single trig function. Usually if you see tangent squared, secant squared, cosine squared, sine squared, you're going to want to use one of your Pythagorean identities, which is on the front page of your notes. It's also, if you're in class, it's right behind me, right above my head. Those are all of those Pythagorean identities. I see that we're dealing with secant and tangent. I believe that's identity 2, Pythagorean identity 2. That was secant squared of x minus tangent squared of x is equal to 1. So this is the second Pythagorean identity, right? What I want to do is I'm going to figure out, how do I get this portion to match that portion? They have secant negative. I need secant negative. They have tangent negative. They have tangent positive. I need tangent positive. What could we do to reverse those signs? We could do that. We could add them or subtract them to the other side. Perfect. Beautiful. You're right. Is there a faster way? What is it? I thought I heard somebody say, yes. We can multiply everything by -1 or divide everything by -1. Yes. So if we divided this entire equation by -1, we have negative secant squared of x plus tangent squared of x equals -1. Okay, remember this right here. This was the original problem that you see in Delta Math. Tangent should be positive. It is. Secant should be negative. It is. If we have that scenario, what does this equal? -1. That's your answer, -1. For that very first parenthesis, I see a cosine squared. So I'm thinking Pythagorean identity. We see cosine squared in Pythagorean identity 1. Agree? So let me start by writing that down. So I have just written down Pythagorean identity number 1. I want to try and manipulate it in a way to get it to match that. So it looks like I need a 1 that's positive and a cosine that's negative. In order to achieve that, I would need to subtract cosine from both sides. Now I'm going to compare. Does what I have just done match the parenthesis? Yes, it does. Then what does it equal? Sine squared. So we're going to substitute. I'm going to substitute what's in parentheses here for what it equals there. Sine squared of x times cosecant. Okay, well, I changed one parenthesis. And whenever I bring down what was in the other parenthesis, we still need to do something else. So I probably can change what was in the second parenthesis to its reciprocal equivalent, and that will help us narrow it down from there. So let me carry down sine squared of x times cosecant. Remember, cosecant is the same thing as 1 over sine. If I were to multiply this out, we would get sine squared of x over sine of x, which would simplify to our single trig function, sine of x. Final answer. Yes, sir, Aura. Okay, if you're stuck on sine of x times secant of x, I don't want to change, not that it's wrong, okay? You could change this original trig function. I'm going to try and change a reciprocal trig function. So I'm going to keep sine of x, sine of x. Secant of x, remember, is the same thing as 1 over cosine. Secant of x is the same thing as 1 over cosine of x, so times 1 over cosine of x. Now let's multiply this out. Sine of x times 1 is sine of x over cosine of x. And as Josh perfectly pointed out, sine of x over cosine of x, that is a quotient identity. So your answer is tangent of x. We have now narrowed it down to a single trig function. Okay, cosine squared of x, let's just leave that alone for now. Secant squared of x minus 1, we have 2 parts of the Pythagorean identity. Secant, that is going to be identity number 2. Very good. So let me write down identity 2. So it looks like what I need is I need a secant that is positive, which it currently is. So let me write that down. I need a 1 that is negative. Well, in order to achieve that, I would need to subtract both sides by 1. And then I need to make sure that that tangent value is on the opposite side of the equal sign from these 2 terms right there. So we would need to add tangent squared of x to both sides. Okay, now does this match what's in parentheses? Yeah. You darn tootin'. Then what can we substitute what's in parentheses? Tangent squared of x. Good. This equals that. So let's use substitution. Cosine squared of x times tangent squared. I see tangent, so I'm thinking quotient identity. Now, anytime you see a square, make sure that you include a square in your quotient identity. So we would do sine squared of x over cosine squared of x. And then as you can probably notice, we're going to be able to cross cancel again, leaving us with sine squared of x, final answer. Muy bueno. Perfect. As y'all mentioned earlier, we want to switch. I see cotangent of x. Cotangent of x is the same thing as cosine over sine. This is a quotient identity. So let's change it. Cosine of x over sine of x times secant of x. Well, that doesn't help us at this point in time. So let's try and converting secant to something else, its reciprocal equivalent. Secant of x is the same thing as 1 over cosine. Now we can start doing some simplifying. We can cross cancel. That would leave us with 1 over sine of x. And do you remember what 1 over sine of x is equal to? Cosecant. Cosecant of x. Final answer. All right. So for this one right here, secant squared x minus 1. I see secant, I see a square. So we're thinking Pythagorean identity. That's going to be identity 2. That's where we see secant. Now, once again, we're going to want to look for how can we move this around to where it matches that on top. I need a secant that is positive and a 1 that is negative. So I need to subtract that 1, bring it over here, and set that equal to, well, tangent of x needs to be out of the picture. So we would add that over to the other side of the equal sign. Now, this matches this. Therefore, that is equal to tangent squared of x. So we can use substitution. Okay, now tangent squared of x. Remember, that is a quotient identity. So I'm going to change that up. So remember, tangent squared of x is the same thing as that over sine squared of x. I kept that. Now we have a keep, change, flip scenario here. We want to keep sine squared of x over cosine squared of x. We're keeping that. Divided by, change it to multiplication, and sine squared of x over 1, if we flipped it, would be 1 over sine squared of x. Cross cancel. We now have 1 over cosine squared of x. That's secant. Good. The reciprocal identity is secant.
Well, what about the 2?
We're going to keep it. Secant squared of x. If you have a square in your end result, keep the square. Okay, cosecant times tangent. If I see tangent, I'm going to want to most likely change it to its quotient identity. So let's start there and see if that helps. Cosecant times, instead of tangent, let's do sine over cosine. Okay, that didn't help. So let me change cosecant to its reciprocal identity, which will be 1 over sine. Cross cancel. We have, I'm so glad to hear that. Now it's not going to be, but what that tells me is you're getting it. That's good. That's good news. 1 over cosine of x. That's the same thing as secant of x. It's reciprocal identity. Okay, so if we're trig factoring, it's really not too much different from basic algebra 2 factoring. So we could rewrite this in a format that we're more accustomed to. I'm just going to get rid of the word sine. So I just eliminated the sign. I made x squared, 3x squared, and then minus 2x. From here, we're going to factor like we normally would. So 3 times negative 1. We need the factors of negative 3 that subtract to get negative 2. Perfect. Now we're going to create a factor by grouping problem. We're then going to group and see what we can factor out. There we could factor out an x. There we could factor out a negative 1. Now we have to remember we're doing trig factoring, not algebra 2 factoring. What did I do? Okay, but thank you. If I catch an error, if I make a mistake, let me know. So now what we want to do is everywhere we see an x, we just want to write the word sine in front of it. So sine of x minus 1. 3 sine of x plus 1. That would be your answer. Tangent squared of x minus 1 algebraically, it's the same thing as x squared minus 1. What we have is we have a difference of perfect squares. 2 parentheses, different signs. In order to fill in these gaps right here, you take the square root of that term, which would be x. In order to fill in these 2 gaps, you're going to take the square root of that term, which would be 1. And now we must remember we're doing trig factoring here. So we just need to write the word tan in front of our x's. I know. For stuff like this, it's just so much easier. But don't worry. What we have here is the algebraic equivalent of 8x cubed plus y cubed. We have a perfect cube factoring problem. And remember, unlike perfect squares, you can factor them whether or not there is a plus sign or a minus sign separating them. In order to do that, you want to use that acronym SOAP. I don't know why I said it like SpongeBob, but I did. Maybe it was the one where the episode where he gives Gary a bath. Did y'all see that one? Yes, you did see that one? That's a good one. That's a classic. Okay, we want to use SOAP. Same, opposite. Always positive. There you go. Same. So we want to use plus, opposite, always positive. We're going to fill in this gap right here by taking the cube root of that term. 2, what'd you say? X. Yeah, you're right, 2x. Good job. Now we're going to fill in this gap by taking the cube root of that term, which is y. That was part A. That was part B. Here's how you fill in the rest. So we're going to take our A term, which is 2x, and square it. Or x squared. We're going to take our A and B term and multiply them. 2xy. Take your B term, which is y, and square it. Now you're going to want to be very, 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 very careful with this one. Are we okay with that? Yeah. Okay, good. Now we have to substitute cosine everywhere we see an x. We have to substitute sine everywhere we see a y. More accurately, substitute cosine of x, substitute sine of x. So here we would have 2x. That would be your final answer. Be very careful how you plug it in on Delta Math because you have to have everything right. $25 is a little bit different from the ones that we've done up to this point. If you would like to follow along, please do. Now, unlike the other ones where we were trying to figure out, okay, well, 1 minus cosine of x, what does that really equal? What I'm going to do here is I'm going to FOIL. 1 times 1. 1 times negative cosine of x. Cosine of x times 1. And now a positive times a negative, which is a negative. Cosine of x times cosine of x. Notice your two middle terms will cancel out, leaving you with 1 minus cosine squared of x. And that makes me think of a Pythagorean identity. Which one do you think? 1, 2, or 3? 1, because 1 is the only one that has cosine squared. I know what you meant, colorblind lady. Yes, this is a part of Pythagorean identity number 1. So we need to move this around so that 1 is positive and cosine is negative. So let's subtract cosine. So what's your answer? Good. This one will put you at 70. Grant, H, what was it again?
Tangent x, or I guess tangent theta times cosine theta minus cosine squared theta.
Tangent theta.
Yeah, or yeah, x. Well, here they have theta.
No, that's fine. X theta doesn't matter, but is it tangent and then cotangent? Okay.
Cosine squared.
Minus cosine squared, you say, huh? Okay. Tangent, cotangent. Where's my cheat sheet? Remember, those are quotient identities. So I could rewrite them as such. That's one way of doing it if you didn't know immediately offhand what you needed to do here. Now, quite possibly the biggest mistake is you'll see, oh, these cancel one another out, which they do. But your answer is not 0. It's 1. And now that looks like a Pythagorean identity. And it is. I think, is this the same answer as the one we did just a second ago?
Sine squared x. is the answer.
Yep.
Yeah, I put that in, it just doesn't work.
Are you putting theta, sine squared of theta? That could be the reason why. Did it work now? Yeah, yeah.